virtual currencies to real estate, and about a couple of years ago I got involved with blockchain. Apologize, I've got a little bit of a cold, so I'll try to speak loud and clearly, but if you could bear with me, I'd really appreciate it. About a year ago I met a development team that I thought was really phenomenal. I started investing in the space looking for scalable solutions that I thought would have the ability to really realize the promises of the blockchain, decentralized autonomous corporations, etc. I found a team that had built some of the largest smart businesses that are truly decentralized today. A team that had been involved with both BitShares and Steam. Some of you guys may have heard of that group, led by Daniel Blumer. And over the last year, we have spent time laying the groundwork for a new smart contract platform called EOS, and I'll give you a brief run through. So this is kind of how we see the landscape. In 2008, Bitcoin proved basically the concept of a trustless ledger and got everyone thinking about the kind of possibilities that we could do when we really started extrapolating out this technology. Lots of little innovation in between. Ethereum, a very well-known project, of course, came along in 2014 and really started to prove the demand for generalized smart contracts. That said, some scalability issues, not able to really release large-scale businesses. If you look at a project like Steam, it would cost about $150 million a year just for the lights to put them on the blockchain. We believe that the solution is a platform that delivers basically high-performance, scalable transactions for a smart business. So what is high performance? We're talking 20, 50, or 100,000 transactions per second, and that's just one medium to large business. These platforms are designed for many businesses built on the same thing, so what we really need is horizontal scalability. We need millions of transactions per second. But the reality of where we're at today is 3, maybe 30, being generous transactions per second by the leading platforms. In addition, to be highly limited on the throughput that we can send on these transactions or these platforms, they're also extraordinarily expensive. So when you look at Ethereum, $3 billion a year to mining, Bitcoin not much better, about $2 billion. Obviously, a lot of fluctuation in the price, but we're looking somewhere between $3 to $5 per transaction. These are some of the slowest, most expensive and limited payment systems that we've ever invented. Now, of course, the peer-to-peer nature of these things are extraordinary, and we still believe that the technology has the ability to change virtually everything. So this is a little bit of history about the CTO, who unfortunately is not here today. Daniel Blumer in 2013 introduced the concept of a DAO. Back then he said DAC, Decentralized Autonomous Corporation. Later DAO was picked up and kind of became a more popular term. We can move forward a little bit. 2014 invented a delegated proof of stake, which allowed higher performance through a proof of stake mechanism, which I'm sure all of you guys are very familiar with. 2015 iterated on that technology, was able to deliver 100,000 transactions in a single chain. 2016, a content platform, a content DAC, was basically designed, conceived, launched, and had 100,000 users per day in less than 6 months. Steam is pretty phenomenal in the sense that most of the people using it don't even realize they're using the blockchain, and 40% of the users are women. So really a great example of blockchain going mainstream, appropriately placed as part of the tech stack and delivering consumer products all on chain without people even realizing. So one of the problems with the blockchain in the past is that then it offers a lot of interesting advantages, but the performance sacrifices that tech teams need to make in order to adopt it are extraordinary, and we need to remove those. So a lot of people don't know this, but if you actually just look at network activity between BitShares and Steam, we're dealing with more transactions per second than both Bitcoin and Ethereum combined, which is pretty phenomenal. And some of these things are actually platforms in which businesses can be built and have had hundreds of millions of dollars funding companies. Even just one DAC, Steam, has exceeded what these people have been able to put out, or these projects. Next. So the problem here is that smart businesses are just too hard to build. We're all interested in building these applications, the decentralized Facebook, Uber, Airbnb, but we're really building on a decentralized computer, but we're missing something, and we're missing the operating system. So what developers are usually normally provided with, databases, account schema, inter-app communication, they're all having to rebuild. And unfortunately, in order to build a proper operating system, it would require more transactions per second than what the existing platforms can even handle. so we don't really have the ability to deliver a thorough, well-built operating system on existing technology. So I'm going to hand it over to Ian to talk a little bit about some of the things that we believe are commonalities amongst decentralized applications. Dan is one of the few people that has actually built and launched these in the past, and it's hard to build a platform for smart contracts when you actually haven't built application-specific blockchains in the past. A generalized platform should really isolate the commonalities amongst everything and provide those in an operating system layer, so we're not reinventing the wheel every time.
So one of the things that's really useful from the perspective of looking at BitShares and Steam and so forth, the lessons that we learned from that is that the way to get scalable applications to the users, to actual users who do actual stuff out there, is to go through the web stack. And consequently, the whole nature of BitShares, Steam, and then in the future EOS, is to consider the web as the go-to platform. We're not talking about downloaded clients, we're not talking about mobile, of course that can be added in. But basically, if you look at Steemit, it is a website. And under that website is all the business logic. Under that business logic is the access to the blockchain. Other processors deal with it in that way as well, or other actors on the various blockchains deal with it in the same way. So oriented towards the web, which means we're going to produce a toolkit which provides basically the web application developers framework to be able to move forward and build. Millions of users basically means a lot of scalability. And the internal tests that we're doing at the moment show numbers like 50,000 transactions per second. We know that the technology, the techniques that we're using have been proven out into the millions in other contexts. So we've got, if you like, confidence that we can get a fair bit higher. And basically millions of users doing millions of things means we just have to have very high transaction throughput, fairly short times. So we're using a block of 3 seconds, which means that basically we can get responsiveness that suits web applications. Free for app users. Now this is a little bit of a difficulty from the perspective of the raw Bitcoin or Ethereum users and various other systems. The difficulty being that the blockchain does need to be funded in some fashion. Now, in combination with the web application concept, if we have a business that's actually interspersed between the blockchain and the users, the business creates the situation where it can finance the user's activity to a certain extent because that's part of its business model. This is what Steam does when you go and open your new blogging account. It'll put a little bit of money into your account. Now, that money is used as a signal for resource allocation. You need a little bit of money to make sure you get access to a little bit of bandwidth. You don't spend the money, you're just owning the bandwidth. So if you are doing something like a Facebook that consumes 9.7% of the resource of a blockchain, you will need to have 9.7% of the issued currency available, because now that means you're owning that particular resource bandwidth. Hence, it is, or it can be, free for the application end user. It's got to be responsive, so hence the 3-second blocks. We don't necessarily think we can go a lot shorter. In time, we might be able to get a bit shorter, but 3 seconds seems to be working for now. This means basically your transactions are generally confirmed within that 3-second gap. For various reasons, the way the governance works, and I know that these questions came up before, the producers that do the mining function, if you like, from the other technologies are organized into a round of 20 or so, and when 2/3 of those producers have accepted the transaction, it is declared final. So within about 40 seconds or so, you reach a state of finality. Upgradable. Because we have a governed chain, this is, okay, so you've all seen the metaphor from, I think, Tim Swanson, for permission chains and unpermissioned chains. So we have Ethereum, Bitcoin, where they're unpermissioned. You can get in there and do things without permission. Then you've got more permissioned opportunities, such as some of the things that have been built, like Quorum, I think, and Corda is very much a permissioned network. There you walk into a walled garden and you can operate according to the rules and so forth. But you have to actually get permission to get into the gate. Now, we are doing something in between. We're doing what we call a governed network, which is to say anybody can enter, but when you enter, you're given the tools to govern the network. And we start out by saying, okay, there's a constitution. It's like an end-user license agreement. It's hashed into the transactions that you do, so it's unavoidable that you have agreed to this constitution. Some of you might recognize this as a Ricardian contract, something I played around with a long time ago. The notion there is we have a basic set of norms and rules to which everybody subscribes, and more importantly, you know that everybody else has subscribed to that. So you've got a basic level of trust, if you like, with the people that you deal with. This allows us to do quite a complicated governance structure, or a very powerful governance structure, because now what we can do is things like revert the disputes that happen between human beings across to dispute resolution, across to arbitration. And we will stand up an arbitration forum for the purpose, which will come from the community itself. So the community will govern its own disputes. And we'll use the same mechanism to choose the producers. The origin of this particular mechanism was the notion of delegated proof of stake, which I think we explain a bit later, don't we?
Go ahead.
Okay, delegated proof of stake. So, and then I finally get to the point of upgradability. Delegated proof of stake. If you think about the way Bitcoin and Ethereum and so forth work, back in the beginning, Satoshi's design was such that we need to preserve the open entry for everybody to go into mining so as to sustain the security of the chain. Fast forward to now, and we don't actually have anonymity of miners. We know where all the miners are. We see them in photos at conferences. There's 8 or 6 of them that control the whole thing. And if we don't know what their names are, we just follow the electricity. So let's flip that on its head and say, okay, let's make the miners known. We know who they are. We're going to make them known. We're going to select them. So what we do in delegated proof of stake is we delegate who the producers of the blocks are. We call them producers. They've been called witnesses and so forth. The names change. Today it's producers. We select who they are as a community process. So up pops in the blockchain the ability to propose yourself as a producer. Now, the community will then vote on you as a producer using its balance in its account, hence its proof of stake, voting on the actual producers. You, as a producer, then go into a round of production with 19 others, and at the end of that round, if you've done anything wrong, you can expect the community to vote you out. It's quite simple. It's just representative democracy, if you like, but it's based on a landholder concept. You have to have land or value in your account to have a significant vote. Now, this mechanism enables us to control problems with the producers. So, if you like, we've got a fairly strong arrangement with the producers, the sort of normal build a block, then the following block gets built by the next producer, and the validity is checked and so forth and so on, and you can have the possibility of forks and drop-offs and things like that. But at the end of the day, at the end of the round, we can also control it with this governance mechanism. We can use the same governance mechanism, essentially voting by stake, to propose upgrades. So when an upgrade is available, coded, tested, we can simply post it up there as a proposal, have it voted, and once that vote goes through, that is the signal for all the producers to, 1, upgrade to the new software, and 2, to shut down when they see the new software goes in place if they haven't upgraded. So there's a sense of moving forward, having to move forward to keep up to track with the community's choice. Hence, it's highly upgradable in contrast to some other systems, and it's built in from the beginning. Account names are provided at the account level, so the keys are not done in a sort of anonymous fashion. It's more done with a naming sense. You don't actually need to apply any information to your name or your account, but you can. And we're going to be using some various advanced identity ideas, which some of you might have heard of from my prior work. That'll come in due course. No purchase necessary. I guess that means free for users.
Yes,
yes, the same thing. Yeah. Account recovery. So one of the problems in the blockchain world is that people are fascinated with the security of the blockchain. But what they're not fascinated with is the insecurity that the users face. If you are on Bitcoin and you get hacked, you're screwed. If you're on Ethereum and something goes wrong with your contract, well, we've got a serious problem. In this system, there is account recovery built in. Every account has a buddy attached to it, and that buddy is selectable. That buddy can help have the account recovered. Thousands of actions per second, well, we talked about that. Bug recovery. So bug recovery, where there are bugs, we can simply use the governance process to pursue a change and so forth and so on. Another thing that we can do with bugs is if you get a contract that does go a bit awry and starts dropping millions of value on the floor, what can be done is a dispute can be filed with arbitration. The arbitrator can look at the facts of the case, decide from the rules, and then come out with a ruling. And that ruling can then be a massive signal to the producers to allow, if you like, an invalid or valid transaction correcting the prior transaction. So we have an ability to back out certain problems or to introduce new transactions where we need to rectify problems. There we go. Okay. Yes. So to get that scalability right up there, we have to change a bunch of things. Firstly, we have to switch across from state. We don't save state in this system, we save messages. So it turns out with state machines, there's two ways to do a state machine. We can save the state, and then the next time we just record that state. Or what we can do is save all the messages in and out to the state machine. As long as it's deterministic, it actually achieves the same result. But what that allows us to do is to have a producer sitting there with all the messages locked up into main memory and be able to very quickly move from state to state with an implied set of state inside. That means we can actually optimize it very, very seriously. And that's kind of the key to how we get this massive fast forward, this processing capability. Now, the other thing is once we've done that, we can also take the smart contract and slice it up into regions. The first region is simply, is it a valid contract? The second region is it validly accessing the various accounts and so forth? So it can be a read-only part. So we start off with validity, then we go to read-only, and then finally we go to read-write, which is to say there's a part where we start writing. Now, all of the first two phases can be massively parallelized. The third phase is the one where we start to get collisions. So what we can do is set up a scheduler, which goes through and analyzes all the things that are touched in that contract, creates islands of contact, and makes the separate islands go out to separate processes. The scheduler itself cannot be parallelized, but practically everything else can. And once we get it down to a very tight scheduler, we can run very fast. But everything else can be horizontally scaled across multiple machines. It comes with asynchronous messaging automatically. The notion that we're trying to build here is that we're trying to do a website delivery of something like Steam and something like BitShares. And it's impressive if you look at those two cases. They're both built on the blockchain. They have nothing to do with each other in use case. So if you imagine BitShares as a trading exchange over here and blogging, social media over there, there's a really wide space between them. And that's open field. So what we want to do is build that capability, that toolkit that allows any sort of application to be built, allowing different use cases to go on top. And this is much the same as we saw the web toolkits come out in the 2000s. Okay, yep. That's good. Yep. Built into this is a database concept. You'll probably have noticed, of course, that Ethereum has a concept whereby you have these hash maps and so forth, these fairly simple key value stores. We are going a step further and giving what is in effect a small, lightweight SQL database to each account user. So instead of having to learn new ideas like hash maps and then map to that to the business concepts, we're giving them the old familiar table construct with indexes and simple queries and so forth. And that's built into the system. The permissioning is all built in. Scheduling, by this nature of having all the messages come into the system automatically scheduled, that's all done. Authentication is going to be part of it. And of course, our contracts are a little bit different. If you think about Ethereum, you post your contract into the blockchain and it sits there and runs away. Whiz, 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 whiz. We don't quite do that. What we do is we take the contract out and place it in a ring around, if you like. You attach each contract as a handler to your account with a message name or a contract name. And somebody sends you a message to your account and contract name. And then that will respond on your behalf and send messages out to others. So if you like, it's a ring with messages flashing back and forth. Hence, inter-application communication is simply find out what the account name is, find out what the message name is, and send it across. That's the middle.
Great. One of the things, just to add on to this, is that the idea here is to massively reduce the difficulty of building smart businesses. The idea is if you built a website, you should be able to build a decentralized application. That's what we really need in order to make this mainstream. Until now, you essentially had to have people that could deal with the protocol level and have the expertise to manipulate those types of blockchains, which is really just a handful of people in the world, also be tremendous product experts. And it's unrealistic to expect that people need to require both in order to build a decentralized application. So the EOS token, as Ian put out, operates a little bit differently. It is not consumed. You don't need to pay for gas or anything like that. If you own 1% of the tokens, you own 1% of the computational bandwidth, storage, and transactions of the network. Obviously, proof of stake, so they're nominating block producers. But perhaps most interesting, EOS doesn't require huge amounts of capital or resources in order to pay the block producers. There's only 21 of them, so it's relatively cheap to run the network, and that's what allows us to get that per transaction cost so low. But we do have a 5% capped annual inflation, and we're able to, the token holders are able to control where that 5% goes into 3 smart contracts. These are called collective benefit contracts. There's certain things that the network needs to provide for all users that it's unrealistic to expect any one user to pay for. And so it's essentially infinite in its governance. I could propose to the network that I'm going to run a foundation and I'm going to market, I'm going to do X, Y, and Z. And I could do it through a centrally administered foundation or a business. And if the network voted for me, that smart contract would transfer that value or those new tokens to me, and then I could deploy them. I could propose a network or a smart contract that just destroyed the tokens. And if the token holders started voting for that, it could take the network to a deflationary or stagnant state. And perhaps most interesting, I can actually build a decentralized application on top of EOS itself, so that I could create essentially funnel money through decentralized budgeting into hackathons or anything that you can possibly imagine. These things can be split, so you may say, why do we have 3? Well, I could simply propose one that split it into 3 more. So the bottom line is a sense of infinite governance that is completely in the hands of the token holders. One of the beliefs that we have is that networks must have a complete alignment between the decision makers and the beneficiaries. When those are split, you start to see problems, right? You start to see networks reach capacity limits, and miners start to say, hey, maybe we won't scale so we can get higher transaction fees, or stagnation in development because people can't get along. So this is just a little bit about our team. We spent a lot of time bringing on people at the top of the industry. We've brought on Blockchain Capital, Fenbushi Capital. We're working with Li Xiaolai and Zen Fund, Sequoia in China. We're working with Bitfinex and Unity. We spent a lot of time planning and iterating these concepts with them over the last year. And of course, this is a community project. So code is on GitHub. Our testnet goes live next month. These are an evolution of technology that already exists. DPoS consensus mechanism has been running now for 5 years with billions of dollars at stake without a single issue. So these are not all new concepts. What we're really doing is generalizing a product that has actually been proven to run the largest smart businesses in existence today. So maybe we can take some questions.
I've got a
Please.
question. So you are talking about buddies being attached with your smart contract. So the whole purpose of the smart contract was what is written in the rule of code is the rule, right? So if you were trying to automate that process and now you're taking a step back by attaching a buddy. And if you look into the game theory or like normal, like what if this buddy turns against you and reverse the transaction.
So this is for accounts, and we're talking about account recovery partners. Do you want to share a little bit about that?
Sure. I challenge your assumption that the whole point of smart contracts was that code is law. That's something that's,
We actually don't believe that it's code is law.
it's something that they've invented. Now, it sounds good, but in practice, things go wrong. We do not have a software industry that can deliver reliable software. Software has bugs, and continues to have bugs. And in fact, most processes are oriented towards pushing the bugs out to the users as part of the test process.
Sorry, I think humans have more bugs than software is.
And humans have more bugs
So let me
than
ask-
software as well, but they're orthogonal.
Yeah.
Put the two together, humans and software work well together as long as they can work with the bugs in each.
So adding on to that a little bit more, smart contracts are parallels to contracts. They're a better expression of legal intent, but law is something that society sets. So I don't actually understand how contracts become law in any case, in any situation, in any circumstance. In that case, it is a platform that's made for perfect code, which is kind of ironic because there's no such thing. So we don't believe that code is law. We believe that contracts, smart contracts, are a more accurate expression of legal intent, and they're still representing people. People will always have disputes, and we need to create something that's more practically implementable to society.
And just to cap that off, I think our target market is businesses. Would a business build, or would an owner put his investment into a platform where he can come back tomorrow and all the value has been taken away? It's just not a robust proposition. A business wants somebody to mind their back because they've got so many other things to worry about. So consequently, we have a softer view of what a smart contract is.
Yes?
I have a question. Actually, I have two questions. The first one is, so the websites, the web layout, is it actually running a light client to the chain, or is it trusting a central trusted server? Like, if I'm building a website, do I have to pick a trusted node that I'm communicating with?
You would run your own node, in effect, on the blockchain.
Okay, so as a business, I have to run my own, or
Yes.
as a user. Okay,
As a user, you'll go to the website of the business.
okay. So from a user perspective, I still have to trust that the business is.
You have
running
to trust the business.
Right.
You have to trust the business,
Okay.
yes. There's nothing stopping you running your own node if you want to,
Okay, okay.
but this is oriented towards businesses providing you with services, blogging, social media, transactions, or whatever it is.
So I agree that the web stack is the best way to deliver a particular service, so you're building for that. But in your talk, you're very much talking about the business. So have you thought more about where you have a network that's quite heterogeneous? You have a whole set of buyers and sellers and producers. And, I think, like, say, in a supply chain, you don't have a business. You have a whole load of businesses.
Mm-hmm.
So have you thought about that and the abstraction layers? And
That is not a market we've looked at. In a previous life, we looked at it quite a lot, and maybe some others will talk about that. But it's not really our target market. It could be done.
So you're more thinking that there's one business running a whole load of nodes.
Yes.
And it's not like different companies all with different
Well,
nodes.
there'd be one business which would consist of many micro businesses coming together to provide that same business. So if you look at the BitShares and the Steemit systems, there are multiple businesses involved. There are some little businesses that do various things like issue certificates for good blogging, provide analysis of the price movements of various things and so forth. So you can have a group or a sector of businesses interoperating, and that would be how supply chain would.
And these websites are essentially just block explorers. Yes?
In your white paper, you talk about you also mentioned here the 3-second block time. And I'm wondering, what enforces this block time on the node level? Because, right, is it a parameter?
Clock time.
Clock time.
Clock time's locked into clock time.
What happens if you have a malicious node running on the network, submitting at faster speeds?
It's not is it a chosen producer?
Yeah, let's say
If
malicious.
it's a selected producer,
Yeah.
and it's
They'd be
selecting
instantly
it.
voted out in seconds because it's so easy to determine that someone's doing that the stakeholders that would suffer from that attack would instantly, it's continuous voting. So you have 20 block producers that are producing at a given second, and then the next 30 are essentially, there's one cycling between them every minute. So there's a lot of people on deck waiting to take that place. and you can automate the software so that those votes could basically drop off instantly.
Hi, I've got two mini questions. So the first is, in the example you gave of Steam and BitShares, they would or they wouldn't be sharing transactions. They wouldn't be on the same network. Or
Well, Steam and BitShares are custom blockchains for their single
Application
purpose
systems.
on separate blockchains.
right.
So our notion is to create one big blockchain so we can bring in the Steams and the BitShares of the world.
So they would. So a Steam node would see a BitShares
Yes.
transaction.
Yes.
Okay. And then the second question is, you mentioned the producers, 20 producers. What incentivizes them if there's no gas, there's no proof of stake, a block creation reward?
They get a block creation reward,
Okay.
and it's interesting. In the Constitution, we set a number, a parameter, and that parameter is a cap for that amount. The producers then, in their round, they choose how much they're going to emit and how much they're going to destroy. Typically, they'll go up to the cap, and that is currently set in our example Constitution at 5%. Now that's too much. They only need 0.1 or 0.01%. Hence, the community will be looking at them to see that they donate the surplus across to these community benefit contracts. So there's a to and fro going on.
And the way that practically works is every time someone makes a proposal to the network to be a block producer, right? Every country, every place where they're actually operating has different operating costs. So I project, I say, this is what it will cost me to be a block producer. And so once all the block producers are voted in, the median of all the prices that have been put forth is paid to everyone. And that's how block producer pricing is decided. Works the same as Steam and BitShares, actually. Yes?
It's a corporate architecture observation, which then leads on to a question about your vision strategy. So the emphasis on using messaging, so data in motion rather than data at rest, is quite novel. Is there any intention to expand into the corporate market rather than the small business?
Yes.
I don't understand.
I'm intrigued by
Yeah.
that aspect.
I think I'd
Just
have to
wondering,
take
is
that
there
question
an intention?
offline because I know you're getting at something really interesting and I can't quite see it, but that's your reputation for asking difficult questions.
So this is event sourcing.
Yes, it is exactly event sourcing.
Without state change,
Yeah.
that's implicit.
And actually, to some extent, I think it works better for the corporate market because you're saving the intent of the players, not the conclusion of the machine. And that should be more legally defensible than the conclusion of the machine.
And most
From a
importantly,
from a
So
contract
from my
point of view.
perspective, it would be interesting to see your thinking down that line in the future.
Yes.
So if you
And-
took a version 2 of Fables.
And just to kind of slide across to ancient history and so forth, event sourcing is how I built Ricardo, which is why I like it.
and just between the switch between hashing state and messaging, I really believe that Bitcoin hash state, really for a simple payment system, it doesn't really matter whether you hash messages or actions or state. And there's been iterations on that, but we kind of stayed on that line of thinking. But if you were running a video game on my computer and I had to get consensus of the network every time a pixel changed, I'd be we wouldn't have video games, right? So this preserves principles that developers are used to and restores the intuitive nature of development to the broad masses of developers.
Never argue with somebody called Dr. Brain.
Absolutely not.
Quick question. What's the programming language for smart contracts?
So we started out with a little scripting language called Ren. And we're hoping to come up with a very clear, high-level description which we could modify into smart contracts. But unfortunately, it turned out to be a little bit slow. We can only push about 1,000 transactions through the tiny little VM that was there. So the development team is now exploring both Ren and WASM or WebAssembly as an intermediate language. So if you like, we've gone and aligned ourselves with the choice of the other major chains, such as Java VM and Ethereum VM and so forth. So the WebAssembly is this new intermediate language for the web browsers, which has been agreed amongst the web browsers and is now moving through as a standard. It so far only has, I think, C, C++, and a couple of other languages like Rust or Go or something. What is it?
Rust also supports compilation to WebAssembly.
Rust, okay.
WebAssembly
right.
is what we're using.
Yeah. So we're limited to those 3 languages as actual top-level languages for the moment, but more will be added in time.
Any other questions?
Is WebAssembly the VM you're using? You have to make it deterministic.
Yes.
So you're modifying it.
Yes.
Okay, we start break time.
Thank
10
you guys
minutes
very
break
much.
time.